For a very quick summary of my framework, we start out by taking the cube, the unit cube, and we define such a thing called the f-completion, which is in some sense, canonical multifoliated system, which we then take a nice subspace of it using an geometric optimization methods to get something like that. And then we view this as a generalized point, so that this acts as like a point in the new space. And say it's a fiber bundle, so maybe the base is Z3 lattice, and this is a fiber over each point in the base. Now, in and of itself, on its own, this is a very, very rich object. The pairwise intersections of the football surfaces, these pairwise intersections, define a four regular graph. The cone manifolds themselves, we can get Bessel modes out of looking what happens near the cone points themselves. So around here, we can get the Bessel ordinary differential equation. We can look at holonomy, which would be like the radial modes. So we take a circular loop here. We can basically look at how it maps onto itself. That's holonomy, the vectors going around, looping back onto itself. And at this intersection junction, at these intersection halfway points, where we define the intersection graph, we can enrich that with an Ihara zeta function, which is sort of like the combinatorial shadow. It keeps track of combinatorics and their spectral information about the graph. By symmetry, each edge length is the same, so they're all length L, so the edges of the graph are length L, making it essentially exactly a combinatorial graph. And we can study symmetries on this object, this point. In particular, the piecewise isometry group, where we slice along this this plane here, cut it in half, and then turn it by 90 degrees. We can do that with other ones too. We can color the elements, so the surfaces themselves, 4 different colors. We can color the loops in the gamma graph, different colors if we want, and thus we get different piecewise isometry groups as a result. I haven't really delved into the spectral tower too much, but this indexes all the quote-unquote seeds that will be used to populate different spaces, fiber spaces. So we take an f-completion dimension 3, we define its canonical subspace, and then use these as points in the new space in the fiber space.